Okay, today we are going to do 1.3, which is measuring central tendency and dispersion using summary statistics. So let's look at what is summary statistics. Okay, so we'll be moving to slide 42. All of you, I believe, should have the slides. Okay, so our learning outcomes for today should be you should be able to recognize summary statistics, meaning you should know what each symbol represents, how to calculate mean and standard deviation using those symbols, and calculating the combined mean and combined standard deviation. So if we look at summary statistics, there will be three items given to you. One is n is the number of data. This is sigma x, or the total summation of x, which is what you use to calculate mean, right? You total up x and you divide with the total number of data. And then you have sigma x squared, okay, or the summation of x squared, which is actually used to calculate standard deviation, as you can see here. So the important fact now here is you need to transfer values in 4 decimal places. If you don't transfer in 4 decimal places, you will see that your answer will be very much different. Okay, for a set X of 20 scores, so what is 20? 20 is your n, the number of data is n. Okay, so this is what you call summary statistics. When they give you the summation of X, 1 to 20 means the summation of data number 1 to data number 20, which is 88. And sigma x squared is the summation of x squared, all right, from data 1 to data 20, which is 420. All right. Okay, so now to calculate mean, basically, how do you calculate mean? You use the formula. All formulas are given to you, so it shouldn't be a problem. So just follow. Okay, when you calculate mean, you need the summation of x. Do you see the 88 there? 88 over 20, you get 4.4. Simple as that. When you calculate standard deviation, in this case, your mean is in 1 decimal place, is fine. But if your mean is in so many decimal places, you make sure when you put it in here, you put it into your standard deviation formula, it must be in 4 decimal places. Okay, so same thing when they give you this, just apply the formula, put the relevant numbers into the formula to calculate. Okay, all right. For combined scores, now this is what I was talking about, where it becomes very technical, where you have to combine two data sets. Okay, you have to combine two data sets. Okay, so now for combining scores, basically when you want to combine scores, basically you want to take two sets of data and you want to combine it together. So let's look at this. So we have to follow the steps accordingly because it becomes very difficult and you can make a lot of mistakes. So first of all, you need to combine the data. You need to combine the summary statistics of the data. Like you need to combine the sigma x, you need to combine the sigma x squared, you need to combine the n. Meaning if I have one set of data with 20 data, one set with 30 data, when I want to combine it, my new n will be 50. That is what it means. Okay, so then after that you'll find the new combined n, because you can see in step 2, like what I mean is the n in data 1 and the n in data 2, if it's 20 and 30 you add up, so the new combined n is basically 50. Same goes to sigma x, the summation of x, you will just add it up to find the combination. Same goes to sigma x squared. You cannot just take two means and add it up to combine the scores. You need to combine it using summary statistics. Okay, then the next step is basically then applying the formula. You will use the combined summary statistics, divide by the new n. Same goes for standard deviation. Again, the repetition here is transferring all values in 4 decimal places, because if you don't do that, answer is going to be very different. Okay, now moving forward, if you look at example 2, here you need to combine two sets of scores, set X and set Y. So this is where it becomes a little difficult. I always advise students to come up with this table. You don't need to draw lines. You just need to come up with whatever that you can see in there. So we're going to use this like I was explaining earlier. This is from data number 1 to data number 20. The submission is 88. Data number 1 to data number 20, the summation of x squared is 420, as you can see. Okay, then you're going to combine data x with data y. Okay, which is data y is now the n is 15, for which they've given you the summary statistics for data set y as well. So now in order for you to find the new mean and new standard deviation, the only way you can do it is you must combine the two summary statistics. Okay, for set x, you just put it into a table. I want you to put it this way. It's up to you, but when you put it into in order like this, you will make lesser mistakes. So you just have set x, y, or set 1 and 2, or a and b according to the question. Then you have n, then you have sigma x squared. I'm going to be using the word sigma. This is sigma, okay? Summation of x, and sigma x squared is summation of x squared. So for the first set, the n is 20 accordingly. Do you see that? And for the second set, the n is 15. Then you just fill it up according to the question. Sigma x given to you is 88, you fill up 88. Sigma x for sigma y is 53, you fill up 53. Sigma x squared here is 420, and for set y is 375. We're just going to use a generalized term here, sigma x and sigma x squared. Okay, but what it actually is 420 is for the first set and 375 is for the second set. So just don't confuse yourself there. So now when you want to combine it, like I told you, the first step is writing this down. Second step, you're going to combine the n, combine all the summary statistics. There's 3 summary statistics, n, sigma x, and sigma x squared. So you are going to combine them. So when you are going to combine them, basically your total for n will be 35. So now you see you have 2 sets, right? One is 20, one is 15. So your total new combination, your combined set will be 35. Same goes to sigma x, you will add it up. Same goes to sigma x squared, you just add it up. All right, then you're back to square one, doing whatever you did in semester 2, where you will apply the formulas that you see here in front of you. You apply the formulas and calculate the mean and standard deviation. So that is how you find combined mean and combined standard deviation. There's only one way. You need to combine the summary statistics. What is summary statistics? The 3 things I introduced to you just now. Sigma x squared, and n. These 3 things is what we need to combine to find. Like you can see here, everything is transferred in 4 decimal places. You can try. If you don't transfer in 4 decimal places, your answer may vary very much. Then it will be a problem. Okay, so now let's look at trying exercise 1.3. Okay, as we are going along, you should be quite well versed with doing exercise 1.3. Okay, I would just like to highlight, I think The rest are okay, except ABC should be all right. I think the problem will arise when you're doing part D. Okay, so part D is a little different, not so different. It's just that here they've given you the standard deviation. Okay, and they've given you sigma x squared. They want you to find mean. You're doing exactly the same thing. Actually, you're just working backwards to find the mean in the formula that you see. Okay, this may look a little complicated, but it's not so. So basically, I would not suggest for you to do it this way. You just put it into your normal standard deviation formula, your sigma x squared over n minus mean squared square root, correct? All right, then you will square it to remove the square root. That's what you are actually doing. What's going on here is you are going to square the formula to remove the square root. That's why you see variance here. Okay, so basically then you fill up all the values to find the mean squared. I don't think it should be a problem. Try it slowly. You should be able to get the answer. Okay, you will finally work it out and you will get 17.47 here. The 17.47 here will be put in 2 decimal places because the question has stated for you to do that. All right. Okay. Okay, so now if you look at question 2, which is on page 29, I think, or page 30, I can't see it clearly here, but it's about there, which is this question 2 for 1.3. For this sigma f is the same as n, as you can see in my slide. What is sigma f? Total frequency. What is total frequency? Is your n. So nothing to be so panicked about that you've never seen this in your life. Then you have sigma fx. Sigma fx is the same as sigma x. Okay, if you look at your mean formulas, they are the same. Nothing so different. Sigma fx squared is your sigma x squared. So you're going to work it out the same way that we just did. So if you want to combine 2 sets, what are you going to do? All right, so it's the same thing. How to find your mean? Basically what you do, you just take 5803 divided by 700, correct? This shouldn't be so difficult. All right, so you will repeat the same steps as I taught you just now. All right, so filling up this table, please sort it out because it's not a problem. Okay, so from page 30, I would like you to highlight the formulas that I've given you in a box. Okay, the formulas that you see in that box is basically, firstly, is this. Mean of x, how do you find mean of x? Is sigma x over n, right? So how do you find sigma x from there? You just cross multiply the mean and n. So that's not a problem. Okay, and then the other formula that's been given to you is based on the standard deviation formula. What we have done here is we've just moved things around to find sigma x squared. Like I told you, if you want to combine 2 sets, you need 3 things. You need n, you need sigma x, and sigma x squared. So basically your aim is to look for this 3, because not all the time they will give you the summary statistics. They will give you mean and standard deviation, and you need to derive the summary statistics from there. All right, so basically what you're doing is, this is your standard deviation formula. All right, so you're going to look for your sigma x squared from there. So I would rather you use this formula because it is faster to do your calculations. So how to find sigma x? You just take your mean times n. As you can see here, how to find sigma x? You cross multiply these two. It doesn't come out of nowhere, it is from the formula. Same goes to the sigma x squared. All right, you move everything around, you will get this mean squared. This is mean squared, not x to the power of -2. It may look such because of the formula, because of the alignment when it comes into Microsoft PowerPoint. All right. So it is sigma x squared is actually standard deviation squared. In other words, this is variance. Plus mean squared. I'm repeating, this is mean squared. I don't want to see you all coming back in April and asking me, is this x to the power of -2? All right. Then you add it up times with n. So as you can see here, there is a bracket there, so please make sure you sort out whatever that's in the bracket first and then you multiply. Okay, so now we're going to work exercise 1.3 question 3 together. All right, so in this case, they have given you a table, so it's easier. But in your exam, what they will give you is they will give you a long worded problem. So from the worded problem, you need to extract the information. They will give you 2 sets and they will give you the end, they will give you the mean. Basically, they're going to give you 6 information. What is the 6 information and all the 6 values that you need to extract from the question is this. They give you, like I told you, how to combine 3 things, right? And mean, SD, they will give you that. So they will give, of course, they have to give you the number of data, they have to give you mean and SD. So this is what you will be seeing in your final exams. These are the questions that are meant that are very technical, can take up to 6 marks. Okay, so for the first set of data, your mean is 61.2, your standard deviation is 13.62, and then you have an n of 23. So what you need to work out is you need to find the sigma x and the sigma x squared. So this is where the formulas that I was explaining to you will come to good use. Because can you imagine if you put the values inside here, oh okay, you put, oh now they give me mean, oh mean is 61.2, my n is 23, then you want to find sigma x, you want cross multiply, fine. Mean is easy, no problem. But what if you need to find standard deviation? Are you going to put in? So it's best that you just use the formulas that I just asked you to highlight just now. Okay, which is sigma x is mean times n. So it's easy. Why? And one more thing is I want you to put it in order like that. It's up to you if you don't want to. You don't need to draw lines. Just put it in order. Or set A, you write n, mean, standard deviation. Set B, you write n, mean, standard deviation. So what we're going to do, we need 3 things, right? We need to combine the n. That's why we have a total of 52. We need to combine the sigma x, we put the total down here. We need to combine the sigma x squared, we'll put the total down here. So, all right, we'll do one by one, okay? So now you have the mean and SD. So how to find sigma x? Sigma x is mean times n. So you can see that 23 times 61.2, you will get 1407.6. So that's all right. That's quite direct. Okay, now how to find sigma x squared? We have worked it out here. Either way, you want to write it as mean squared plus standard deviation squared, or standard deviation squared plus mean squared is the same thing, okay? All right, so it's 61.2 squared plus 13.62 squared. Make sure you add those 2 up first, and then you multiply with 23. But if you wish to put it into the calculator one shot, it's also easy. Okay, 23 times bracket 61.2 squared plus 13.62 squared. And you will get the value that you see here for sigma x squared. Please make sure it is in 4 decimal places. All right, because can you imagine rounding off so many values? Eventually, you're going to get a very different answer. Okay, then same thing you are going to do for set B. All right, you are going to find sigma x. How to find sigma x? Mean times n. 29 times 59.1. You will get 1713.9. All right, and then how to find sigma x squared? Basically, you will find sigma x squared using the formula that we have been using from just now. Okay, sigma x squared is, if I were you, I'll put it in the calculator directly. 29 times bracket 59.1 squared plus 14.91 squared, according to the formula here. You can just put it in the calculator. Make sure you put a bracket if you want to put it in one shot. It'll be easier, you make less mistakes. Okay, then like I told you, if you want to combine, you need to combine your n. Therefore, we total up our n. Our new n is 52. And what is our new sigma x? You add up both the 3121.5. And then what is your new sigma x squared? You add up both, this is what you get. So this is what I meant by very technical. Any mistake made in between, everything will be wrong. And a question like this is easily 5 marks. 3 marks for your combined standard deviation, 2 marks for your combined mean. Sometimes it can go up to 6 marks if the numbers are very big. All right, so after you are done with this part of the table, then it's again back to the same thing. You're going to calculate your mean using the formula. Do you see? Your new combined sigma x divide with n. Your new combined sigma x squared divide with n. Put your 4 decimal places in here. Do you see that? Here your final answer, they want it in 2 dp. That's why it's like that. But when you transfer 4 dp, that's why I always encourage students, write it in 4 dp first, then you round off accordingly. Okay, then you put it into the formula and you calculate as usual. Okay, so it shouldn't be so difficult. It should be quite doable. Okay, so if you look at question 1.3, you will have the same question that will, you have part ABC, pretty much quite similar. Part ABC will be the tables that you need to fill up. Okay, so let's sort that out for now.